Okay, let's go ahead and get started. Thanks for coming along today. As I said, my name is Jonathan MacDonald. I'm a solutions engineer here at the Information Lab. Part of my role is to look after our AWS partnership, and I spend a lot of time deploying Tableau servers onto AWS. So I thought I would put together a little session on tips for deploying Tableau Server in the AWS cloud. So I tried to come up with a nice round number of tips, ended up on 11. So you can think of 10 tips plus a bonus. And I'll spend the next sort of 30 to 45 minutes talking through some of these. Feel free to pop questions in the chat. And I can try and address those questions when we get to the end of the session. Just some quick housekeeping notes. We will be recording this session and posting it to our YouTube channel at the end, along with any links to relevant documentation. So if you do want to recap on this or have a look at any links, then keep an eye out on our YouTube channel. You'll be able to find it there shortly after the presentation finishes. So let's dive in. I guess the first tip when thinking about installing Tableau Server in an AWS environment is picking the right architecture. So before you've done any deployment at all, it's worth having a think about what kind of Tableau Server architecture do you want to deploy? Now, Tableau Server can be installed on a single node, a single VM, but you can also scale that out and run Tableau Server across multiple nodes if you have a requirement for serving many users at that level. So have a think about. It's worth having a think about whether you want to deploy a single node or a cluster, how many users you're going to be serving in that environment, whether you have high availability as a requirement. So with Tableau, you need a minimum of 3 nodes to achieve a high availability quorum. So that kind of almost insists on having a 3-node cluster there at least. What type of data sources will you use? So if you're connecting to certain data sources that only have database drivers written for Windows, for example, then you might need to deploy a Windows instance. But otherwise, you can use Linux. If you are deploying a Tableau server to be used in an embedded environment, and by that I mean you are sort of creating visualizations and publishing them to a Tableau server and then embedding those dashboards into another web page, you might have slightly different requirements there as well around security. For example, if you're exposing your Tableau server to the public internet, you may want to review how you architect that deployment. And any add-ons as well. So, for example, the server management add-on or the data management add-on. These are 2 products that you can purchase additionally from Tableau, which have their own set of requirements. The server management add-on, for example, comes with a tool called the resource monitoring tool, and that needs to be deployed on a separate server. So these are just some of the questions to think about before you deploy. Maybe try and have some answers to these questions written down, which will help guide you through the documentation to find the right type of architecture. So my next point here is just on trying to do some more documentation. So when we deploy Tableau servers here at the Information Lab, we typically use infrastructure as code approach, specifically CloudFormation. Tableau and AWS have done some work together to put together some great Quickstart templates, which are CloudFormation templates that help you automatically deploy a single node or multi-node cluster on various different flavors of Linux and also on Windows. You can find those templates. They're on GitHub. If you have a Google for AWS Tableau Server Quickstarts, should be the first result that comes up. But having a look at these templates, really kind of guides you through a number of variables that you should think about when you're deploying your server. Things like the IP address range to allow through the firewall. What license key are you activating your Tableau server with? What type of authentication are you going to use on your Tableau server, and so on. It's necessary, I think, and important to write all of these down beforehand, and then use that in your sort of infrastructure as code approach to deploy a sort of repeatable environment in an automatic way. So the next tip is to use these AWS Quickstarts. It's the easiest way by far to deploy Tableau server infrastructure. I can't recommend them highly enough, really. I would recommend that if you're new to AWS and specifically new to using CloudFormation, then perhaps spend a bit of time becoming familiar with how CloudFormation works, understand how templates are put together, because what you can do is take these Quickstart templates, which are really just JSON templates which describe the infrastructure that you're going to be deploying, and you can customize them to your environment. For example, if you wanted to use a different type of authentication method, if you wanted to configure your Tableau server to use SAML single sign-on, or if you wanted to install some custom database drivers, then you can go and modify the template to do all of those things when it deploys. And what that's going to give you is a nice documented, repeatable description of your infrastructure. So I get a lot of questions about what type of instances to use for Tableau on AWS. The biggest point here is that is the note at the bottom of the screenshot, which says that the T2 instances, and that extends to the T3 instances as well, are not supported. And that's because those instances have burstable compute capacity, as well as memory capacity as well. And they just don't play nicely with Tableau. The recommended instances are the C5 4x large, M5 4x large, and R5 4x large. These all provide 16 vCPU, 16 virtual CPUs, which really work out to the equivalent of 8 physical cores, which is the minimum number of cores you need for a production Tableau server environment. The memory on these machines varies though. So with the C5, I think you're getting 32 gigs, the M5 64 gigs, and the R5 128. I would recommend going with at least 64 gigs. So when we deploy Tableau servers here at the Information Lab on AWS, I choose the M5 4x large, which gives you a good combination of RAM as well as the required compute capacity as well. Another really handy tip for deploying Tableau on AWS is choosing the right disk size, the right size of volume where you're going to deploy Tableau. So with AWS, the disk throughput is burstable. Broadly speaking, the larger the disk, the better the throughput you're going to get from that disk. I can go into a bit more detail here, but roughly speaking, the GP2 volumes, the general purpose volumes, are SSDs. And those SSDs accumulate credits, input-output credits, at a rate of 3 IOPS per gigabyte per second. And that accumulates and accumulates and accumulates. And then when your disk is under heavy load, those credits start draining out. And if you happen to run out of these credits, then you're left with a baseline level of throughput. which works out at three IOPS per gigabyte, which is the amount of credits that are coming in per second, which is really not enough to run a Tableau server, or it's really not enough to run any kind of service, really. So you want to make sure that you provision a disk that's large enough so that you're getting enough credits coming in so that those credits will never be used up. And that's why the speed of the disk is roughly tied to the size. Here at the Information Lab, we deploy Tableau servers with a minimum GPT volume size of 500 gigabytes, which ensures a baseline of 1500 IOPS, which should allow your Tableau server to perform sufficiently. My next point is about high availability. So, you might have a requirement in your organization to deploy a highly available Tableau server, if it's a business critical application, for example. The first thing you really want to do here is think about your RTO and RPO. So it's recovery time objective and recovery point objective. The recovery time objective is, how much time do you have to recover the service, and the recovery point objective is how long can you wait before recovering from a restore point. Have a think about these KPIs, and that will roughly dictate how you do HA with Tableau. As I mentioned earlier, you need a minimum of 3-node cluster for Tableau's definition of high availability. And what I mean there is that Tableau Server has a component called the cluster controller, another component called the coordination service. So Tableau Server itself can automate some failover of some of the components in the cluster, but it's not real high availability per se, because there are some manual steps that need to happen in the event that the initial node, which is the sort of the primary node in a cluster, falls over. So you may consider doing HA in a different way, and that will come down to how you've defined your RTO and your RPO. So let's say, for example, that your recovery time objective is to restore the service within 4 to 6 hours. If that's the case, then you can maybe consider running a hot standby server. You could also consider perhaps just redeploying the environment with your infrastructure as code approach. When I deploy a single node Tableau server on AWS with that CloudFormation template that I showed you earlier, that takes about 20 to 25 minutes to build. So you can actually get your environment back quite quickly using that approach. And it may mean that you don't need to go down the road of sort of Tableau's high availability option, where you're spinning up multiple nodes in a cluster and then having to manage the failover process for that cluster. So something to consider there, but it all starts with defining your RTO and your RPO for the service. My next point is just about keeping your house tidy. So I've seen a lot of instances lately where Tableau server logs have grown and grown and grown and just consumed all of the disk space on a Tableau server, and that resulted in the server falling over. And then it takes some work to recover and get that service back up again. It seems a simple one, but it's really important to archive and clean out your log files, at least on a weekly basis. You can achieve that by running a command on the Tableau server initial node The command is the TSM maintenance cleanup command. And what I tend to do is script that command to run weekly on a weekend. I have a GitHub repository with a number of housekeeping scripts that I can send you the link for once this video is up on YouTube. And you can just grab those scripts and drop them into your cron or your Windows task scheduler and let it do the work for you. Backups are also important. So VM snapshotting, for example, is not a supported method of backup for Tableau Server. You do need to take an actual Tableau Server backup using the TSM maintenance backup command. You can optionally schedule that to run automatically in Tableau Server version 2020.4 and later. The server itself will let you, automate that backup process. I guess another obvious point here, but save those backups once they're created on the local machine. You want to make sure those are pushed up to S3, for example, so they're saved off of the server. And then in S3, you can implement something like the lifecycle management rules to expire those older backups, because you don't want to be keeping backups for years and years. You can just plug a lifecycle rule in to expire the backups after 30 or 60 days, or whatever you choose there. So my next tip is just around securing your environment. So I would always recommend to use an application load balancer. And a question I often get on that is, well, if I've only got a single node Tableau Server, what's the point of using a load balancer? And one of the main benefits is really just to take care of auto-renewing SSL with Certificate Manager. So with AWS, you can get a certificate into Certificate Manager, and you can use that with an application load balancer. And if Certificate Manager is automatically managing the renewal of that cert, then SSL is just taken care of out of the box. There's no manual steps to install certificates on the VM. There's no process that you're going to have to do in a year's time to upload a new renewed certificate onto the machine. AWS Certificate Manager combined with an application load balancer just takes care of all of that for you. Additionally, with an application load balancer, you can configure web application firewall. Now, there's a great CloudFormation template called WAF Security Automations. So that's Web Application Firewall Security Automations, which you can run, and it will create a whole set of default rules for protecting a web application from malicious, your usual malicious attacks, things like cross-site scripting, HTTP floods, and the like. So I would definitely recommend having a look at that security automations template. You do need to be a little bit careful here, because sometimes it can block valid traffic. For instance, we've seen just some of the default rules in the WAF security automations deployment will block traffic between a Tableau desktop and a Tableau server. But feel free to reach out to me if you are considering looking at that. I think we've got a blog post coming out soon on how you can mitigate that. But WAF security automations is a great way to protect your Tableau server instance, especially if you're exposing it to the internet. So you might have a use case where you're exposing dashboards to a public audience. Some other tips here, Tableau provide a security hardening checklist. Just some things to go through. That's what you see in the screenshot on this slide. This is the checklist. This is step 3 in the checklist. Just talking about how you have the option to disable different TLS versions if you need to. The last 2 points here are just around encrypting your EBS volumes. So AWS lets you encrypt your GP2 EBS volume. So that's your storage volume for your Tableau server. That's an easy way to do a volume level encryption. AWS takes care of all of that out of the box. Additionally, on your Tableau server itself, you can enable extract encryption at rest, which will encrypt your individual extract files. But that is a user setting, so you can either turn it on and enforce it across your whole server, or you can enable it for users to turn it on and off for specific extracts, or you can turn it off globally. My last point here is just about storing the credentials in Secrets Manager. So Secrets Manager is an AWS service which controls or manages your secrets, things like TSM, usernames and passwords, and so on. So if you are deploying your Tableau server using an infrastructure as code approach like CloudFormation, you can leave those credentials out of the template and instead refer to the ARN, the resource identifier in Secrets Manager. So AWS will just go and fetch the credentials out of there, so that no passwords are passed through the template in plain text and that sort of thing. So once we've got our Tableau server up and running and secured and deployed, we want to make sure that it's monitored. We don't want any surprises that have our servers going down in the middle of the night. So this is when you can use AWS Cloudwatch. There's various different ways that you can monitor your server. On a basic level, Cloudwatch will monitor, pretty simple VM metrics like CPU consumption, disk I/O, and memory RAM on the VM. That's memory component does require the installation of a Cloudwatch agent on the machine. The next step up from that is to collect process specific stats. And I'm talking about, I'm assuming here that we're deploying Tableau Server on Linux. All of these rest of these points talk about how you can collect metrics from a Linux server. And Cloudwatch lets you collect process-specific stats with a small tool on the Linux machine called ProcStat. And what that'll do is it'll send metrics from the machine to Cloudwatch around the resource consumption for each of the processes running on the server. The next level up from that is to collect the JMX counters. So most of the sort of important components on a Tableau server are Java applications, and you can collect specific metrics for those Java applications around things like the number of VizQL sessions, the number of queries that each VizQL session is generating, the number of active sessions, and the memory and CPU consumption of each of those sessions. So that really gives you very detailed, granular information about what's going on your server. The way that you can collect those JMX metrics is to use a CollectD plugin for Cloudwatch. You can set that up on the machine and it will send that JMX data to Cloudwatch where you can monitor it in the dashboard. There's lots of other ways to monitor these metrics as well. The server management add-on comes with a tool called the Resource Monitoring Tool, which is it's a paid-for add-on, but it lets you monitor the same metrics. There's also a chap out in the community called Tamas Foldy. In a recent blog post, he talks about how you can set up a InfluxDB and Grafana application and send these metrics to that instead. So you don't have to use Cloudwatch. You could use any of those other solutions as well. Once you're monitoring all of those metrics, you can decide to be alerted about them as well. And Cloudwatch lets you configure any kind of alerts on any of those metrics and send them to an SNS topic and a simple notification service, SNS. And that can then post that notification to a number of different outputs. So it could just be an email, or you could send it to a Slack channel, or any other kind of internal social media that accepts a webhook. So I was going to talk a little bit about how the server management add-on can save you a bit of time. Server management add-on, if you've not heard of it, is it's a pay-for add-on that gives you 6 extra features that help you manage a sort of enterprise-grade Tableau Server deployment. A couple of these features are really handy when you're running Tableau Server on AWS. The top one here that I wanted to highlight is the ability to externalize the Tableau Server repository into RDS. So if you don't know, the repository is the metadata store for a Tableau Server. It's a PostgreSQL database, contains all of the Tableau Server metadata, things like usernames and permission sets and groups and projects and workbook names and so on. But that Postgres component runs on the server itself. And you have the ability in a multi-node cluster to run active-passive configuration of this component. So you can have 2 nodes, one which is running an active Postgres repository and one which is running a passive. So you can have a sort of a failover option there. But with this add-on, you have the option to externalize that repository entirely into RDS, into a Postgres server and RDS. That just buys you, quite a lot more redundancy if you are looking at sort of a sort of rock solid HA environment requirement. Another feature that can be quite handy for running on AWS is to externalize the encryption key off of the Tableau server into AWS Key Management Service. So what this does is the encryption key that is used to encrypt extracts at rest exists on the server itself. This option allows you to take that key off of the server and store it securely in AWS's own key management service, so that when your extracts are being encrypted, they're using a key that doesn't exist on the server itself. So that's, again, in an environment which has really high security requirements, that can be quite a handy feature to have. Some of the other features you get with the server management add-on aren't really AWS specific. So the resource monitoring tool, the content management tool, the external file store are all really handy features, but they can be used in any Tableau server environment. Okay, so we're on to my last slide, which is just around managing costs. So these are some tips to keep your costs for Tableau server down. My first recommendation here is to use reserved instances or savings plans. So if you're not using those, you definitely want to have a look at them. By default, when you spin up an AWS environment, it runs on an on-demand basis. But what you can do is commit to running your infrastructure for a defined period of time. With a reserved instance, you can commit to running it for 1 year or 3 years. And you can also pay for that commitment upfront or monthly. And that affords you some really significant discounts. So you can get sort of up to 60 or 70% off if you commit to running your Tableau server for 3 years and you pay for all of those 3 years upfront. And that's the sort of most extreme scenario. My second recommendation here is to always deploy on Linux, unless you are connecting to things like MS Access, which only has a Windows driver. You don't really need to deploy on Windows anymore. And on AWS, Linux instances are significantly cheaper than the Windows instances, up to 50% off. It's also worth looking at the AMD-powered CPU instance types. So before, when I mentioned an M5 4X large as being a recommended instance type, there's a relatively new instance type called the M5A, which uses AMD processors instead of Intel ones. And that works out at about 10 or 15% cheaper than the Intel M5 instances. So I've tested that. The M5A instances work great. There's no issues. Tableau Server runs fine on them. And then my last tip is just think about engaging an AWS partner when you are thinking about this deployment. Partners of AWS, like ourselves, are able to get funding from AWS directly for proof of concept. AWS will fund the cost of the infrastructure up to 4 weeks, which gives you, firstly, free of charge month of running a server. But secondly, it gives you time to sort of tweak that tweak the infrastructure and get all the settings and the configuration right. Get your infrastructure as code written out before you go into production. AWS also offer some really good incentives if you're migrating your Tableau Server workload onto AWS from, for example, on-premise or from another cloud provider. They will give you up to 15% off of the first year's cost of doing that. All of this stuff has to go through an AWS partner. So if you are looking at migrating a workload, then it's worth getting in touch with either ourselves, myself, or with another AWS partner of your choice. Okay, I think that is everything from me. Thank you very much for watching. I'm going to just have a quick look and see if we had any questions. Feel free to pop some questions into the chat if you have them. Okay, so we have a question from Steve. If you selected Windows already and want to switch to Linux, how hard would that be? It's pretty easy, Steve. The method to do that would be to take a backup, a Tableau Server backup. So that's using the TSM maintenance backup command, which will create a tsback file. That file contains all of your content of your server, and you can save that off to S3, and then redeploy a Linux instance and restore that backup. The backups are compatible across operating systems from Windows to Linux. I don't believe you can go the other way around. So a Linux created backup doesn't work if you try to restore it on a Windows instance, but you can switch from backup to from a Windows backup, restore it to a Linux instance. Great, no problem. I have another question about whether I have a preference on Windows or Linux. I always choose Linux. There's some caveats there. Like I mentioned, there are some data sources which don't have drivers for Linux. Off the top of my head, I think Teradata and Microsoft Access are the two that come to mind. Hopefully no one's using MS Access anymore these days, so that shouldn't be too much of an issue. But do have a look on the Tableau's tech specs page. There are little asterisks next to the supported databases. which tell you whether they are supported on Linux or not. But yeah, otherwise, Linux is definitely the way to go in the cloud. It's so much cheaper. Anecdotally, the performance is better, I believe. There are some blogs out in the community which where they've done benchmark testing, and they've shown Tableau Server on Linux to be quite a bit faster than on Windows. And yeah, I mean, I guess you probably do need to have a little bit of Linux expertise in-house. You know, if you've never used the Linux operating system before, then yeah, that might cause issues if you then have to go in and troubleshoot. But yeah, otherwise, I would recommend Linux over Windows almost every time. Another question on whether what advice might I have before getting started with AWS? That's a good question. One key piece of advice before getting started with AWS. I think it's important to just plan everything out in advance. What I've seen too much of, unfortunately, is folks just diving straight into AWS and launching a Tableau Server template without sort of a whole lot of thought given to the network environment, all of the configuration, the right instance size, the right disk size. So a lot of the tips that I went through earlier. Definitely take the time up front. Use a partner, use an AWS partner or a Tableau partner to plan out how you want to run the server, how many users are going to be serving, and so on. And yeah, with AWS, all of this stuff can be so easy. It can automate an awful lot of processes, which can be really tedious if you do them on premise. But you need to use the cloud in the right way. So, so sometimes you need to change your thinking a little bit around that. But yeah, plan in advance is my answer to that. Any other questions? Otherwise, I think we'll wrap up. Yes, we have another question from Guido. Guido, the customer is more on Azure than AWS. Is the deployment similar, or are there more caveats in Azure? Good question. I've got to be honest and say I'm not hugely familiar with Azure, certainly not as much as I am with AWS. But the process is roughly the same. I believe there is an Azure Quickstart equivalent for Tableau, and Azure have their own kind of language, infrastructure as code language, like AWS has CloudFormation. On Azure, I forget what it's called right now, but it's a way to sort of write out a template to deploy the infrastructure. So more or less the similar approach. Are any other caveats running on Azure? You probably have some more question marks around what operating system to choose. I think I know it on Azure, there's quite a lot of encouragement to run a Windows server, especially if you're reusing on-premise licensing in the cloud. I know that's an arrangement that Microsoft have sometimes with some organizations. So yeah, you may want to have just give a little bit more thought to whether you use a Windows or a Linux OS. Okie doke. I think we are just about there, unless there are any other questions.
Doesn't seem to be any other questions. Thanks a lot, JMac. It's been great to listen to your advice on tips on AWS. The recording will be available shortly, so please keep an eye on that on our YouTube channel, and you'll get an email from Meetup with the link as well. So thanks again, JMac, and goodbye, everybody.
Thanks all. Bye for now.